Good day, ladies and gentlemen. Today I'm going to teach you how to do homology modeling. So first and foremost, you need to look for the sequence of your protein of interest. Okay, so to do that, you go to NCBI. So in NCBI, this is the website. So, and there are a lot of databases here. So you go to protein, you select protein, then you come to the search bar here, you type the name of the protein you are interested in. So in this case, we are going to use chitin synthase of Bulinus species. And this Bulinus species, they are species of freshwater snails that are harboring schistosoma species, and this schistosoma species are the parasite that causes schistosomiasis or bilharziasis. So you click in search, you click on search, then look at the information that is displayed. You have chitin synthase class 1, partial sequence from Bulinus truncatus, which is one of the species of the Bulinus genus. So, and this is another chitin synthase class 2 from Bulinus truncatus, but this one seems the sequence, this first one is because it's partial, the sequence is 715 amino acid in size or in length, and here the length is 2,362 amino acids. So I will take this one, you click on it, then the information here will be displayed. Okay, you see the assertion number and all the information, the journal from which this information was derived. You see it, and also the sequence here of the protein. Okay, sequence of the protein is here. You can see. Okay, now so before you take the sequence of the protein, you can run a blast search to search for regions of similarity between this particular sequence and the sequences of other species. So you can run BLAST. BLAST is basic local alignment search tool. And here it automatically brings the assertion number here. So you leave everything here by default. You go down, you see it's already by default it's selected protein blast P, which is protein blast. So you just click on blast and wait for the results to appear. The reason why you are doing this blast search is to see whether other species are having this same protein. So when you do this blast search, it will bring up the species that are similar to the species that have this particular protein, and it will arrange it based on the highest similarity. The highest similarity, which is from the chitin synthase class 2, the one you use to search, to do the blast search, is 100%, and all other ones below it, the percentage identity will be lower than your query sequence. So you can see we have chitin synthase from Bulinus, from Bionfolaria, also Bionfolaria glabrata. This is another species of freshwater snail that causes that harbor schistosoma mansoni parasite that causes intestinal schistosomiasis. This is another Bionfilaria piphidae, another species of Bionfilaria. And you have another snail here, Bionfilaria glabrata, limnia species, and so on. So this information is important. You can save this sequence. You can take this sequence individually and save them in case if you want to carry out multiple sequence alignment. You can do multiple sequence alignment here, or you can go to, you can download Mega 11 or Mega 12, the latest version, and then import the sequences and plot your phylogenetic tree. And that phylogenetic tree that you constructed is going to indicate the evolutionary relationship between the sequences in the various species. But for today's video, we are not going to do multiple sequence alignment. That will be a topic for another day. So here you can see, then you can go back. That is just to give you an idea of the protein sequence in the similar protein in other species. So we can go back. Okay, now since you are back here, what you will be taking, you now save the sequence, but in FASTA format. You click this FASTA. Now, this is the protein sequence. You can copy everything from here, and you can open Microsoft Word and save the sequence in case if you are going to come back to it. But since we are just going to go ahead and do the homology modeling, you just copy. You can copy the sequence alone without the name. Copy the sequence, copy, and you open, you go to Swiss model, Swiss model. There are two ways you can do the there are two ways that you can do the modeling. You can use Swiss model, or you can use AlphaFold. So for today's video, we are going to use Swiss modeling. So you start modeling, click on start modeling, then you import. Here it says paste your target sequence, or you can import them from UniProt. So since we have our sequence, you can now Control V, paste the sequence. Okay, you can now give the project name. You can now give it a title. Let's say chitin synthase. Chitin synthase of Plinus species. Then you can add email. This is optional in case if, because it's going to take time. So in case if the work has completed, you will be notified via email. So since we are going to wait here, let's just go ahead without inputting our email. So you can start by searching for templates. It will search all the databases, including AlphaFold, to check for similar structures that are there. The reason why you are doing homology modeling is you want to predict the structure of the protein from the amino acid sequence. So you can go ahead and build model. When you click on build model, it will search the templates first and then build the model for you. So you click on build model, and it's going to take a few minutes to now build the model for us. So we are going to wait a little bit. Okay, now our homology modeling result is ready. So you can see it has generated 50 templates and build 6 models for us, 6 models. So you can expand this so that you view the models. You can see the first model on top, it has percentage identity 12.72. Go down, the next one, it has percentage identity 13.00. This first one is polypeptide N-acetyl galactosamine transferase 4. Okay, so this next one is cellulose synthase catalytic subunits, 13%. This is cyclic beta 1,2 glucan synthetase, 14.52. This one is 20.25. And then this last one, it has percentage identity 72.77. So here you select the one that has the highest percentage identity. So this is chitin synthase, and it's actually a model from AlphaFold database. And from this organism, Formatia canaliculata, which is also another species of snail. So you can download files here, click here, you download in PDB. There are so many formats here, but you download in PDB format since your aim is to do molecular docking. So you click the PDB format. So it's already saved here. Okay, you can see it's built the model for you as model 01. So you can use this model for your molecular docking. So you can also check for the you can plot Ramachandran plots using the model to see amino acids that are in most favorable region and those that are in unfavorable region. So this will enable you to check for the geometry of the generated model. So you can use saves. This saves database, which is used to analyze your protein structure. So you can use under these saves, there are different database under it. So we are going to use the ProCheck. So you can select your protein, which is this model. You now click run programs. It will display all the available programs for you. So what we are going to be doing is we want to check the stoichiometrical quality of our protein structure. Here we'll check the residue by residue geometry and the overall structure geometry. So you can, under this project, you can click start. It has started analyzing, and your result will be ready in a short while. Okay, so now we can see that our project analysis is completed, and we have our result here. You can click on the result. So we can see that our Ramachandran plot is ready. We can see the plot here with the information at the bottom. We have residues in the most favored regions. We have 87.6%, and additional residues in allowed regions, 10.7. and all this information is important, so that you can save it. And here you can save it in, you can click PDF, and then you save it. Okay, that is all. Thank you for watching.